atom cannot exist independently. So what do? They combine with each other and form molecules, right? Here the nucleus and the internal electrons are represented by the symbol of the element and the valence shell by dots or crosses. The one electron which is present extra in sodium is being transferred to chlorine. It could not explain the stability of molecules containing number of electrons which are odd like NO and NO2. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So in today's session, we will be discussing on what is chemical bond. Yes, then we'll move on to Queisel-Lewis approach to chemical bonding. Then we'll study about Lewis representation of simple molecules, then formal charge, and finally the limitations of octet rule. Right, so we know that what is matter made of. Let us begin with the basics itself, right? So what is matter made of? We know that matter is made of tiny particles which is called as atoms, right? So in the beginning, early times, it was told that atom is not divisible, right? Then after many discoveries, it was found out that atom is divisible and it consists of electrons, protons and neutrons, right? Regarding all this, we discussed in the previous chapter. Yes, so we know that, as I said, matter is made up of tiny particles called atoms. So what you have to understand is, atom cannot exist independently. Right, atom cannot exist independently. So what do? They combine with each other and form molecules, right? This is already known. So what you have to understand is atom cannot exist independently. So it will combine and form, that is different atoms combine and form molecules. And molecules can exist independently. So the question arises, why do atoms combine? Why exactly atoms combine and form molecules? As said, they can't exist independently. So they combine and form molecules because they hence attain stability. Right, as I said, atoms do not have stability on their own. So they combine and form molecules to attain stability. Clear? Now the next question, how do atoms combine? We understood that atoms do combine, right? Now, how do atoms combine? So atoms combine by forming chemical bonds between each other. Yes, they form bond between each other. So what is this chemical bond? Let's see the definition. The attractive force that holds different constituents together in a chemical species, it is formed either by the transfer of electrons or by the sharing of electrons. So it is basically an attractive force that is between the atoms which holds together the constituents, that is the atoms, right? The atoms together in a chemical species. So in any chemical species, the attractive force between the atoms, that is called as chemical bond. So how is this chemical bond formed? Either by the transfer of electrons or by the sharing of electrons. This in detail we will study in the upcoming slides. Okay, so that is chemical bond. Right, so you might have seen bonds being represented by this single line, right? So this line is actually representing the bond between carbon and carbon atom. So what you have to understand is, there exists no line like this. Actually, there is no line present inside the compounds, right? It is actually an attractive force which is present between the atoms, which for our ease, it is represented by these lines. It is actually an attractive force. Yes, so that is about chemical bonds. Now, does all atoms combine? That is another question. We understood that atoms do combine. Why do they combine and how do they combine? By forming chemical bonds. Now, does all the atoms, whichever atoms are present, do they combine? Yes, about this, we have studied about noble gases, right? Yes, what was the speciality of noble gases? That belongs to the 18th group. What is the speciality of noble gases? They are stable, right? They have already attained stability because they have completed an octet in their outermost shell. Yes, so they are stable. So what happens? They do not generally take part in chemical reactions, but there are few exceptions. So in the case of noble gases, we can say that they do not combine with any other atoms, right? So I hope these three questions, the answer of it is clear for you, right? So now in detail, we are going to study about chemical bond, right? So many scientists proposed many theories on this chemical bonding, how exactly this chemical bonding will take place, right? So in this chapter, we will be studying in detail about the chemical bonding theories which were given by different scientists. So we are beginning with the Coastal-Lewis approach to chemical bonding. Yes, we are going to see Coastal-Lewis approach. How did they approach? Like how did they explain the chemical bonding that is present in the different compounds, right? So Coastal-Lewis approach, there are two scientists, Coastal and Lewis. We are going to study about that. So according to Lewis approach, atom consists of positively charged kernel and the outermost shell that can accommodate 8 electrons. Right. So what did he say? According to the Lewis approach, we know that, yes, what have we studied till now? There is a positively charged nucleus, right, in which neutrons are also present and the electrons will be revolving around it. Yes, that is what we have studied. So what according to Coastal-Lewis approach is that this whole part except the outermost shell which contains the valence electrons, right, they are called as valence electrons. So except the outermost shell containing the valence electron, all the inner shells plus the nucleus, that is this whole part you can see, right, this whole part except the outermost shell is called as kernel. Yes, this is called as kernel and there is an outermost shell, that is outermost valence shell containing the valence electrons. So he categorized that atom is having only two parts, that is one is the whole of the inside, nucleus plus all other shells is considered as kernel and then outermost shell containing the valence electrons as another part. That's it. So why did he consider like this? So we know that if this atom wants to combine with another atom, the inside electrons which are present, right, they won't be taking part in the chemical reaction. Only the outermost electrons will take part in the reaction, right? See, if this is an atom and I am combining it with another atom, yes, what happens? Only the electrons which is present here and here, yes, take part in the reaction, right? So what he did is he gave no importance to the inner shells and the nucleus which is present inside, only to the outermost shell. Yes, so this is how they represented atom. Yes, so to represent these atoms, yes, so to represent this atom according to Coastal-Lewis approach, Lewis developed Lewis symbol. Now, what exactly is Lewis symbol? Let us see. So, in the formation of chemical compound, only the outermost electrons participate and in these electrons are called as valence electrons, right? We just saw that now. This part is the kernel and only the valence electrons take part in chemical bond formation, right? Yes, the inner electrons are well protected and they are called as core electrons. Yes, now, G. and Lewis introduced simple notations to represent valence electrons in an atom. Yes, as said, there is a kernel and there are valence electrons with the valence shell wherein valence electrons are present, right? So, just the valence electrons, how using that you can represent a atom, Lewis formulated Lewis symbol. Okay. And here the nucleus and the inner electrons are represented by the symbol of the element and the valence shell by dots or crosses, right? And then Lewis symbols are informative. It gives the valency of an atom which is either equal to the number of dots or equal to 8 minus the number of dots. So let us try to understand this from the examples itself. So how do you represent different atoms using Lewis symbol? We are going to see. So it is how many valence electrons are there? According to that many number of dots you have to represent it here. Yes, so let us take the example of hydrogen. We know that in hydrogen only one electron is present, right? So how do we represent hydrogen in Lewis symbol? Yes, hydrogen, you write the symbol of it and then you put a single dot here, right? Because it is containing only one valence electron. Coming on to helium. We know that helium consists of 2 electrons, right? The electronic configuration is 1s2, right? So, there are 2 valence electrons which are represented by 2 dots, right? Now, for lithium, we know that what is the electronic configuration for lithium? 1s2, 2s1, right? Again, 1 valence electron. So, it is represented by 1 dot. For beryllium, it will be 2 dots. As you can see, 2 dots. Boron, it is 3 dots because the outermost valence electrons. The number of valence electrons are 3. So based on this, you can represent the different atoms. Yes, so what you have to see, it is just the number of dots you have to put around the symbol, which is equal to the number of valence electrons. So if you want to represent sodium, okay, I want to represent sodium in the Lewis symbol. So we know that first we have to find out how many valence electrons it is having. So we know that what is the electronic configuration? 1s2, 2s2, 2p6 and 3s1, right? Again, it is having one valence electron. That means Na and one dot. Clear? So I hope that is clear. So this is how you represent Lewis symbol. Yes. Now, one more point is there. Its Lewis symbols are informative. It gives the valency of an atom, which is either equal to the number of dots or 8 minus the number of dots. Yes, so we have studied about valency in the last chapter as well. So if I am considering carbon, yes, what is the valency of carbon? It is either equal to the number of dots or it is equal to 8 minus the number of dots, right? So in this case, we know that the valency of carbon is 4. Right? So 1, 2, 3, 4. It is equal to the number of dots. Right? Let's take the case of nitrogen. Yes, it is number of dots given here. That is equal to the number of valence electrons. It is 1, 2, 3, 4, 5. Right? So 5 is the number of valence electrons. But what is the valency of nitrogen? It is 3, right? Yes. It requires only 3 more electrons to complete its octet. So it's better for it to accept 3 electrons rather than losing 5 electrons. Right? We studied this in last chapter. Right? So what is the valency of nitrogen? It is 3. So that is 8 minus. So that will be 8 minus the number of dots, which is 5. That is equal to 3. So from this Lewis symbol, you will be also able to calculate the valency of the atom. So this is clear. So now moving on to the next part, that is octet rule. So we already know what is octet rule, right? To attain stability, atoms, what do they try to do? They complete their octet. That is, they try to attain 8 electrons in their outermost shell. Right? Yes. So according to this rule, atoms undergo chemical reactions in order to attain an octet of electrons in their valence shell, or atoms containing 8 electrons in their valence shells are stable. So why exactly atoms try to attain 8 electrons in their outermost shell? To attain stability, right? So this is octet rule. Yes. Now how this octet rule is being attained? Right? We know that 8 electrons are to be attained in the outermost shell. But how it is done? Yes, either it is by the transfer of electrons or it is by the sharing of electrons. Yes, so let's take the first one, by the transfer of electrons. So what types of bonds will be formed when there is transfer of electrons? Yes, so chemical bond formed by the complete transfer of one or more electrons from one atom to another is called as ionic bond. Right? We have already studied about ionic bond. That is, electrons are transferred from one atom to another atom. That way, a chemical bond is formed. So that they attain, both of them attain stability, or both of them attain octet. Right? Yes. So this is the by the transfer of electrons. So for this, let us take the example of sodium and chlorine. Okay. Yes, so for sodium to attain its octet, it needs to lose 1 electron, right? So the number of valence electrons is 1 because the last shell is 3s1. We know that. So before that, there is 2s2 and 2p6. Yes, so if it loses this 1 electron, now what will be the outermost shell having? The number of electrons will be 8, right? So it will attain octet. So what happens? It is easy for it to lose this 1 electron. Right. So this 1 electron is extra in here for it to attain octet. If it loses that 1 electron, yes, it will attain octet. Now moving on to chlorine. Yes, it needs 1 more electron to attain its octet. Right. It is having 7 electrons in its outermost shell. If it gets 1 more electron, it will attain its octet. So what happens? The 1 electron which is present extra in sodium is being transferred to chlorine. Right. So if sodium is losing 1 electrons, it becomes Na plus ion, right? Losing 1 electron, right? And Cl is, that is chlorine atom, is gaining 1 electron. So that also attains its octet. So that becomes Cl minus ion. And there a bond is formed between Na plus and Cl minus, which is called as ionic bond. I hope it is clear. Now moving on to the next way. that which octet can be obtained is by the sharing of electrons. So, by sharing of electrons, how does this happen? So, bond formed by the equal sharing of electrons between atoms, right? So, electrons are contributed by both. Then, what kind of bond is formed? It is formed, covalent bond is formed. So, to understand this, now let's take the example of two chlorine atoms. Instead of taking one sodium and chlorine, I am taking two chlorine atoms. So, we know that each of this chlorine atom will be having 7 valence electrons, right? It is having 7 valence electrons. 1, 2, 3, 4, 5, 6, 7 and 1, 2, 3, 4, 5, 6, 7. So, we know that each of them will be having 7 valence electrons, right? So, if this chlorine atom attains one more electron, gets one more electron, it can fill its octet, right? And the same way, if this chlorine atom gets one more electron, that is this chlorine atom also attains stability or attains octet, right? So, what do? They share the electrons between them. Like, it is not transferring from here to there or there to here. They share the electrons, right? So, how I can represent it? They both share these electrons, right? Hence, there will be a bond formed in between them, which is called as covalent bond. Covalent bonds are formed by the sharing of electrons, and ionic bonds are formed by the transfer of electrons, right? So, as you can see here, now this chlorine atom, let's see if it attained 8, right? 1, 2, 3, 4, 5, 6, 7 and 8, right? And this atom 1, 2, 3, 4, 5, 6, 7 and 8. So, both of them attained octet, right? So, I hope this is clear how atoms attain their octets either by the transfer of electrons or by the sharing of electrons, right? So, now we are moving on to the details of covalent bond, which are the different types of covalent bonds that can be formed. So, we know that covalent bonds are formed by the sharing of electrons between two atoms, right? So, first one, as you can see, it is single covalent bond. So, how is this single covalent bond formed? So, what is single covalent bond? When two atoms share one pair of electrons, they form single covalent bond. As you can see here, the example that we just discussed now, yes, this chlorine is having 7 electrons in its valence shell and this is having 7 electrons. Now, what do? Each of them require, that is 1 electron each. That means 2 electrons of a total, which gives 1 pair. See, as you can see, 1 pair of electrons is shared between both of them, right? Yes. So, what happens? A total of 8 is obtained for both the chlorine atoms. Only 1 pair of electrons is shared, so a single bond. So, as you can see here, yes, one chlorine atom, 1, 2, 3, 4, 5, 6, 7 and another chlorine atom, 1, 2, 3, 4, 5, 6, 7. So, this 8 and this 8 and they share 1 pair of electrons between each other, hence forms a single covalent bond. Now, moving on to double covalent bond. Yes, when two atoms share 2 pair of electrons, a double covalent bond is formed. So, as you can see here, yes, how many number of valence electron does oxygen have? It is 6, right? So, 1, 2, 3, 4, 5, 6, which is contributed by this oxygen atom. And 1, 2, 3, 4 and 5, 6 which is contributed by the other oxygen atom. Now, both of them share this 2 with each other. That is 2 pairs or 4 electrons with each other. So, what happens? Yes, this oxygen atom attained its octet 1, 2, 3, 4, 5, 6, 7, 8 and even this oxygen atom attained its octet. So, there are 2 bonds which is shared, that is 2 pairs of electrons which is shared between them. So, that becomes O double bond O, right? So, this is double covalent bond. Now, moving to triple covalent bond, when 2 atoms share 3 pair of electrons. So, let's take the case of nitrogen. As you can see, how many number of valence electrons are there in nitrogen? It is 5, right? Yes. So, 1, 2, 3, 4, 5 and the other nitrogen atom also has 5 valence electrons. Now, what do? They share 3 pairs of electrons with each other. So, what happens? Even this nitrogen atom and this nitrogen atom, both of them attain octet, right? 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen atom got 8 and the same way other nitrogen atom also attained its octet. So, how you can represent it? N triple bond N, right? Yes, and there will be 1 lone pair each on this nitrogen atom. So, yes, that is clear. Even in this oxygen, you have to represent these 2 electrons as well. Yes, so I hope it is clear. That is single covalent bond, double covalent bond and triple covalent bond, right? So this is called as single bond, double bond and triple bond. Clear? So till now we studied how you can represent Lewis symbol for different atoms, right? So now we are going to see how for polyatomic molecules, that is more than one atom is present, how we can represent the Lewis dot structure or Lewis symbol. So there are few steps with which you can do this. So the first one is you have to calculate the total number of valence electrons of the combining atoms. The second step is each anion means addition of one electron, each cation means removal of one electron, and this gives the total number of electrons, okay? And the least electronegative atom will occupy the central position, and after placing the shared pair of electrons for single bond, the remaining electrons are either used for multiple bonds or as lone pairs. So to understand each of the steps, let's take one example and go through each of the steps. Right. So I am going to represent carbon dioxide in Lewis dot structure. So how do I do it? The first step is how you have to calculate the total number of valence electrons. So what is the total number of valence electrons? In carbon, there is 4 valence electrons, right? So in carbon, how many valence electrons are there? It is 4, right? And in oxygen, there are 6 valence electrons multiplied by 2. There are 2 atoms of oxygen, right? So 6 into 2, that is 12. That give you a total of 16 electrons. Yes, so we calculated the total number of valence electrons. Like if anions are present, we have to add one electron, and if cations are present, we have to remove the number of electrons. But as you can see, it is a neutral molecule. There are no charges present. So second step we can avoid. Now, the least electronegative atom will occupy the central position. Now, we know that there are a total of 3 atoms here, right? So where do I position carbon or where do I position oxygen? So for that, you have to see which atom out of it is least electronegative. So out of carbon and oxygen, carbon is least electronegative. So carbon is placed in the center and oxygen is placed on either side. Okay, so till here it is clear. Now after placing shared pair of electrons for single bond, the remaining electrons are either used for multiple bonds or as lone pairs. So what you have to do after representing this? Yes, one each single bond you have to represent. So one single bond means there are 2 electrons, right? 1 and 2. So a total of 4 electrons is already gone. So a total of 16 electrons were there, out of which 4 electrons I have already represented in the form of single bond. So that gives a total of 12 electrons now, which I have to either represent it by lone pairs or double bonds or triple bonds. So let's start. The 12 electrons, how to represent it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I represented the 12 electrons. Now what you have to do is, you have to see whether each of this atom is attaining octet, right? Yes, so let's begin with the oxygen. This oxygen, 1, 2, 3, 4, 5, 6, 7 and 8. Yes, this oxygen atom attained its octet. Yes, now coming on to this oxygen atom, 1, 2, 3, 4, 5, 6, 7, 8. Even this oxygen atom attained its octet. So coming on to the carbon, 1, 2, 3, 4, right? Only 4 electrons in its outermost shell, right? So this carbon did not attain its octet. So all the atoms should obtain octet, right? So what can I do? I can transfer this double bond over here and this double bond over here. So what does it finally become? Yes, it becomes O, C, O, and this 2 electrons is being represented here, means that becomes another single bond, right? So this becomes a double bond here and double bond here. Now what else is left here? 2 pairs is left here. 1, 2, 3, 4 and 2 pairs is left here as well. Right? Yes. So now let's see. Carbon attained 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now all of them attained their stability. So this is how you represent the Lewis dot structure. I hope it is clear. Yes. Right? Even this attained its octet, and even for the carbon, it attained its octet. Clear? So now let's take 2 more examples and understand how to represent the Lewis dot structure of it. So first one is NF3. So how do I represent NF3 in Lewis dot structure form? Yes, so first you have to calculate the total number of valence electrons, which is 5 in the case of nitrogen, and for fluorine it is 7 for each fluorine. That means into 3 will give 21, right? That is a total of 26 electrons are total valence electrons. Now out of this I have to find which is the least electronegative one. It is nitrogen. So that will be in the center. Now 3 fluorines are represented here. Yes. Now I give single bond to each of it. Right. That's the next step. Now out of which 1, 2, 3, 4, 5, 6. 6 electrons are gone as, yes, represented as single bond. So that means a total of 20 electrons are there. Now we have to represent it. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18 and 19, 20. Yes, yes, we know that for nitrogen the number of valence electrons is 1, 2, 3, 4, 5. Right. So a total of 20 electrons are now represented here. Now we have to see if each of them are obtaining octet. Right. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All the fluorine are attaining 8 electrons. What about nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. Even nitrogen has attained its octet. So this is the Lewis dot structure for NF3. Yes. Now moving on to the next example, that is CO3 2 minus. So first step is to calculate the total number of valence electrons, which is equal to 4 plus for oxygen it is 6, right? So 6 into 3 is 18. Now what do I do with the 2 minus? Yes, 2 minus charge. Yes, as you can see, each anion means addition of 1 electron. So as you can see here, minus charge means it is anion, right? So if there are 2 minus means, that means an addition or an extra of 2 electrons is present in this compound. So that should also be added in the total number of valence electrons as 2, which gives a total of 24 electrons. Right? So that's clear. If it was CO3 minus, then instead of plus 2, it should be plus 1. So I hope it is clear. Yes. And if it's a positively charged, that is if it is cation, then 1 electron must be subtracted from it. So yes, that is clear. Now out of carbon and oxygen, yes, carbon is least electronegative one. So carbon in the center and 3 oxygens are represented here. Yes. Now 1 single bond is represented. Yes, 1, 2, 3, 4, 5, 6. So from this 6 electrons are being removed. That gives a total of 18 electrons now, which has to be represented by lone pairs or double or triple bonds. Right. So let's start from this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17, 18. Right. This is clear. Now let's see if each of them attained octet. Here it is 8, here also it is 8, even here it is 8. All the oxygen atom attained octet. But what about carbon? 1, 2, 3, 4, 5, 6. Only 6 electrons. But it has to have 8 electrons in its outermost shell. Right. So what can be done? One pair of electrons can be made into a double bond. Yes, the oxygen and carbon can share it between them. So how does the representation become now? It will be double bond here, single bond here and single bond here with the 2 pair of lone pairs here, 3 pairs of lone pairs here and 3 pairs of lone pairs here. So as you can see, now all of this attained the octet, right? And one more thing that you have to remember is, yes, it was CO3 2 minus, right? So this 2 minus must be represented there. So I hope that is clear. Yes. Now this is about the Lewis dot structure. Yes. Now moving on to the next part, that is formal charge. So as we just now discussed about CO3 2 minus, so exactly in which atom this 2 minus charge is present? Is it present in this oxygen atom or this or the carbon atom? Which is holding this 2 minus charge? Right, that we don't know. We know that the whole of this compound is having a 2 minus charge. But which atom is exactly having this charge is not predictable. So to understand that and calculate it, a new topic was introduced, that is formal charge, a new term. So what is formal charge? Formal charge on an atom is equal to the total number of valence electrons present in the free state of that atom minus the total number of non-bonding electrons. Non-bonding electrons means which the number of lone pairs. right, which means the number of lone pairs minus half of the total number of bonding electrons, right? So let's consider O3 molecule and understand. So what is O3? It is ozone, right? So this is the structure, Lewis dot structure. Now what we are going to do? We are going to find out the formal charge, right? The charge with each of this oxygen atom we are going to find out. So I am representing this as 1 and this is 2 and this is 3. So the first one we are going to calculate the formal charge of the first atom, first oxygen atom. So what it is? Formal charge is equal to, yes, what it is? Total number of valence electrons in the free atom. Yes, for oxygen atom we know that in free state how many valence electrons are there? It is 6, right? Minus, yes, total number of non-bonding electrons. So in this particular oxygen atom, how many non-bonding electrons are there? That means, yes, which are lone pairs, right? So, yes, there are 2 electrons, right? So that means 2 minus half of what? Total number of bonding electrons. So how many bonding electrons are there? So that is taking part in the bond formation. So this oxygen is having a bond with this and this oxygen atom as well, right? So 1, 2, 3, 4, 5, 6. Yes, a total of 6 bonding electrons are present for this particular oxygen atom. So that is 6, which gives 3, right? Which gives 6 minus 2 minus 3, that is 1. Yes, that is 1. So what you can see from here, from the calculation you are able to understand that this particular oxygen atom in ozone is having a +1 charge. Clear? Now what about this oxygen atom? We are moving to the second oxygen atom. So what is formal charge? Yes, it is equal to the total number of electrons in free atoms, which is here also 6, minus the total number of non-bonding electrons. Yes, as you can see, 1, 2, 3, 4, 5, 6. Yes, there is 6 non-bonding electrons, that is lone pairs. And how many bonding electrons are there? Yes, 1, 2. This is only showing a bond here, right? It's not having a bond with any other oxygen. So that is 1 by 2 into 2 electrons. Yes, that means 6 minus 1. Yes, that gives -1 charge. So what you can see, this oxygen atom is contributing a -1 charge. Now coming on to the third oxygen atom, the formal charge will be equal to the total number of valence electrons in its free state, which is again 6, minus the number of lone pairs, 1, 2, 3, 4. Yes, 2 lone pairs are there, that means 4 electrons, right? -4 minus half of what? Yes, the total number of bonding electrons, minus half of the total number of bonding electrons, 1, 2, 3, 4. 4, right? So it becomes 4. That means 6 minus 4 minus 2. That gives 0. So on this oxygen atom, there is no charge. So what you can see, here is a positive charge present. Here a negative charge is contributed. So that means a positive and negative charge will neutralize each other. So in total, O3 molecule is having no charge. Clear? That is why no negative charge or positive charge is represented there, because out of the 3 oxygen atoms, one is contributing a positive charge, one is contributing a negative charge, which will be neutralized, and finally the O3 molecule is not having any charge. So I hope formal charge is clear for you. Yes. Now we are moving on to the last part, that is limitations of octet rule. So we studied how do atoms attain their octet, right? Yes, by transferring of electrons or sharing of electrons. Now, there are certain limitations for octet rule as well, which we will be discussing. Yes, so first one is incomplete octet of central atoms. So, it could not explain the stability of compounds containing less than 8 electrons around the central atom. So, there were certain compounds which were not having 8 electrons in its outermost shell. That means, yes, we know that to attain octet or to attain stability, they need 8 electrons. Right, but there were certain compounds which were not having 8 electrons, but still they were stable. So they couldn't explain that is octet rule couldn't explain the stability of such compounds. So as you can see, for lithium chloride, yes, LiCl, lithium contributes 1 electron, yes, and chlorine requires 1 electron, right, to attain its stability. So what happens? A pair of electron is shared between them, that is 2 electrons are shared between them. So chlorine will be able to attain its stability, that is 8 electrons, but lithium will only get 2 electrons, right? So that means it is less than 8. That is one example. Now moving on to next one, that is beryllium hydride. Yes, so for BH2, we know that hydrogen requires duplet, right? So hydrogen will be able to attain its duplet, not octet, yes, duplet. But beryllium will only have 4 electrons, not 8. Right? The same goes for BCl3 as well. Each chlorine atom will be able to obtain its octet, but not boron. Right? As you can see, 1, 2, 3, 4, 5, 6, only 6 electrons, not 8. Yes, so this was one limitation. For certain compounds, yes, those were having less than 8 electrons, they were stable, but couldn't explain the stability of them. Now, odd electron species. It could not explain the stability of molecules containing number of electrons which are odd, like NO and NO2. Yes, for NO if we see, yes, what is the total number of electrons? It is 5 plus 6, which is equal to 11, right? 11 electrons are present in the valence shell. Yes, so that is odd number species. So as you can see here, for nitrogen 1, 2, 3, 4, 5, 6, 7. Only 7 electrons, but for oxygen it is attaining octet. So in the same case of NO2, as you can see, both the oxygen atom is attaining octet, but not the nitrogen. Yes, for these kind of species also, the stability was not able to be explained. Then moving on to the third one, that is expanded octet. Yes, so these are having more than 8 electrons. Yes, they are not satisfying the octet. They are having more than 8 electrons. Yes, so it could not explain the stability of molecules containing more than 8 electrons in the central atom. That is expanded octet. So as you can see, one example is PF5. Okay, so each of the atom must contain 8 electrons in its outermost shell according to octet rule, right? So as you can see here, each of the fluorine atom is able to attain its octet. But coming to phosphorus, what is happening? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons around the central atom. Right. Now moving on to SF6. Here also, all the fluorine atoms are attaining octet. But what about sulfur? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 electrons are there, right? And the same goes with H2SO4. So, these are the 3 limitations. Now moving on to the next one, that is octet rule is based upon the chemical inertness of noble gases. Yes, but some noble gases like xenon and krypton form compounds with fluorine and oxygen. So in the beginning also we studied that, yes, as noble gases has its octet completed already, they are highly stable. But there are exceptions as well, right? So what happens is xenon and krypton combines with fluorine and oxygen and forms various compounds. But according to octet rule, this shouldn't be happening. Then this theory does not account for the shape of the molecules. Yes, what will be the shape of these different compounds and different molecules that we have discussed till now? What are the shape of this? No idea about this was given. Yes, and it did not explain the relative stability of the molecules. So these 6 were the limitations of octet rule. Yes, so in the next class, we will be discussing on ionic bond. In this class, we discussed in detail about covalent bond, right? We will be discussing on ionic bond and the factors affecting formation of ionic bond parameters in which we will be studying atomic radii, bond angle, bond enthalpy and bond order. And finally, we'll be discussing on resonance structure. So I hope what all we have discussed in this session is clear for you. So that's all for today. Thank you.